These are the Kitakami Mountains, awaiting the arrival of spring. Magma that erupted in the Cretaceous period of the Mesozoic era hardened over several million or tens of millions of years and formed granite deep underground. In the bedrock of the Kitakami Mountains, the most advanced particle experimental facilities may be built for uncovering the secret behind the birth of the universe. This is the ILC project, an international project the likes of which has never been seen before. Tohoku is pulling together to make this project a reality. I visited this school to meet children from Tohoku. This is a school within the Eichi domain in Sendai. Students from grade school to high school are energetically studying. Let's take a look. This school has sister schools in 71 countries. Grade school, middle, and high school students are all full of energy. The children are reading books.
何の本読んでるの？オゾンホールの。オゾンホール。はい。へえ。宇宙のことに興味あるの？少しはあります。へえ。大きくなったら何になりたい？
宇宙飛行士。
なんで？
宇宙でいろいろなものを見てみたいから。
Let's take a peek at this classroom. This looks like a class on the universe. Let's listen in.
They say that the Big Bang came from this little tiny particle that exploded into this huge universe we saw here. And the universe is very likely to get even bigger. In fact, there are research facilities where we can do experiments about the time right after this explosion. In fact, between Miyagi Prefecture and Iwate Prefecture, right in the middle, they might research facilities.
The candidate site for these facilities is right here in the Kitakami Mountains.
北上山地の岩盤にリニアコライダーが作られるんですね。
The official name of these experimental facilities is the International Linear Collider, or ILC. Linear means straight line, while collider means something that causes a collision. The facilities will be 31 kilometers in length in a straight line. The impact from vibration and changes in the environment will be minor, since the collider will be built 100 meters underground. High school students are having a chemistry class.
We used to learn that the atom was the smallest particle in chemistry. However, the atom has an internal structure made of things like protons and neutrons. Are protons and neutrons really the smallest units? If we create a higher energy state, we find that there are elementary particles inside protons and neutrons.
What is the ILC project?
The instrument for investigating elementary particles is called an accelerator. The ILC features one type of accelerator, a linear one. Many accelerating units are placed in a row, and electrons and positrons are released. Electrons and positrons are accelerated from both ends of the 31-kilometer tunnel at speeds approaching the speed of light. These particles have head-on collisions, and the elementary particles that shoot out are then studied. We are now moving ahead on a collaborative project among scientists from Europe, America, and Asia, examining where the ILC should be built. In order to conduct high-precision experiments, The geological foundation must be absolutely stable. According to a geological survey, the bedrock beneath the Kitakami Mountains is composed of hard granite and stretches over a wide area. The ideal conditions for construction are found in the area around the cities of Oshu and Ichinoseki. The results from the survey prompted industry, government, and academia in the Tohoku region to get together and form the Tohoku Conference for the promotion of the ILC, for the purpose of attracting the ILC. Tohoku University, a member of this organization, has turned out such distinguished scientists as the Nobel Prize winner Koichi Tanaka. It's a base for groundbreaking Japanese studies in such fields as particle physics, cosmology, nanotechnology, and medicine. In particular, the research accelerator at Tohoku University is indispensable for numerous industrial and academic fields. We talked with President Satomi of Tohoku University, who is also a representative official of the Tohoku Conference for the promotion of the ILC.
Because there are many technologies in which Japan is the eminent leader, other countries expect a major country like Japan to step forward for hosting these facilities. Under the collaboration of industry, academia, and government, a new town will be built for the ILC, where scientists from around the world will live comfortably with their families in a truly international city.
The journal Nature, an international authority in science, stated the following: US and European scientists should throw their support behind the ILC project. An early show of support could give the collider the push it needs to get underway. That would be a great victory for Japan and the world.
What can we learn with the ILC?
This is the CERN, Particle Physics Research Lab along the French-Swiss border. Over 10,000 scientists from around the world are involved. Here, there was a major discovery in 2012 with the LHC, or Large Hadron Collider.
Because we hear two presentations from the two experiments, Atlas and CMS. We have observed a new particle consistent with a Higgs boson.
The Higgs particle was finally seen more than 50 years after its existence was first postulated. Higgs particle, the source of mass for all elementary particles, was discovered. We talked with UC Berkeley Professor Murayama, director of Kavli IPMU, who is at the forefront of elementary particle physics. What were you feeling when the Higgs boson was discovered?
Tears came to my eyes. Really? Why do things have mass? This is a real mystery. You know the famous equation by Einstein? E equals mc squared. E stands for energy, and m stands for mass. If you think of this as a constant, this is saying that mass is energy. For example, inside your body, there are particles called protons. And if you look inside the protons, there are even smaller particles called quarks. These quarks are bouncing around like crazy inside the proton. This energy is what we feel as mass. But there was still a mystery. There are other particles, called electrons, moving around and around that, together with a proton, form an atom.
The thing that gives mass to these electrons is the Higgs boson.
You would think that space is just empty, right? Well, in reality, space is filled with Higgs bosons. They're everywhere. When an electron tries to pass through, it is slowed down. Because it is slowed down, it is able to go into orbit in an atom. Space is filled with these, creating a system. Until now, we were unable to find the particle responsible for this.
Well then, what will be studied and discovered at the ILC?
When the universe began, it was very small and very, very hot. It was clearly smaller than even an atom. And in this incredibly small space, extremely hot things were jammed together. This led to the Big Bang. In order to study how the universe began, we need to investigate the reactions that occurred in this very small space. In the test we would like to carry out at the ILC, if we collide small particles with enormous energy, we can reproduce the conditions of the beginning of the universe right here in the laboratory. That is how special this equipment is.
What type of things will you find out?
We are all made up of atoms. You were probably taught that all things were made up of atoms, right? Well, that is a lie. A lie. If we look at what space is really made up of, out of 100%, the percentage of atoms is only about this much. Not even 5%. So what is the rest?
The parts we don't know are things called dark matter and dark energy.
We would like to study things like dark matter and Higgs particles in more detail. That is the dream of the ILC. ILC technology.
As we move towards making the ILC a reality, research and development is proceeding on research apparatuses with assistance from the High Energy Acceleration Research Organization. Researchers and manufacturers are aligning forces to create an apparatus that is only one of its kind in the world for such technical advances as creating more effective acceleration equipment, a superconducting cavity, and a means to rectify the deviation in a long-distance beam down to the nanometer level of accuracy. Technology, invented through leading-edge research, is promising for expansion into a variety of fields, including industrial applications and medicine.
Japan has had a long-term lead in heavy particle radiotherapy, a leading-edge technology. If the ILC comes into being, new medicines may be created, and new treatments that cannot even be envisioned today are likely to be developed as related technologies. The development of such unimaginable treatments is particularly likely for cancer. In this sense, we have great expectations for the project.
For the benefit of Tohoku.
In 2011, the ancient city of Hiraizumi at foothills of the Kitakamis was recognized as a World Heritage Site. Structures from the Middle Ages have transcended time and even survived the power of magnitude 9 earthquake. It was a kind of Shangri-La created over the 3 generations of the Fujiwara Oshu clan, who lived here during the period of civil unrest in the hopes that the Pure Land of Pure Land Buddhism would be embodied on earth. And now, the 21st century. We are once again passing through a time in which human civilization pushes out its horizon as ambitious plans lie before our eyes. According to an estimate by the Tohoku Conference for the promotion of the ILC, the economic spillover from ILC construction and operation will reach an estimated 4.3 trillion yen. Also, 250,000 new jobs are expected to be created. Many scientists and technologists will come from around the world to the ILC. Business and research organizations with an interest in accelerators will also gather to give birth to new innovation. Building such an international research city will invigorate the economy, industry, transportation, and tourism, giving a spur to earthquake restoration. Those who come here from numerous countries can live in comfort and enliven culture, education, and the arts through cultural exchanges. In the novel Night on the Galactic Railroad by Kenji Miyazawa, Giovanni, the lead character, makes a vow to his close friend Campanella. Let's seek the happiness of all people. Suddenly, the figure of Campanella in front of Giovanni's eyes disappears and is replaced by the mystery of an admonishing old man. You should make an experimental method to divide truth from lies in your thoughts. This is to seek the greatest happiness of all people. And this is a road you should travel with Campanella.
When these children reach the time when ILC is up and running, the facility will have become a major means of support for the community and a pillar of the family. When the ILC Research and Development Center is complete, the dream of a study platform for children in Tohoku will be accomplished. It will make them conscious of the world and global society. Seeing people doing research and similar activities with people from around the world joining hands will truly make us happy.
Childhood dreams and the yearning of youth will surely create a future society where they are essential. The outside world was impressed that no unrest occurred as a result of the recent earthquake. Instead, there was a culture in which coexistence with nature, along with cooperation among people and human ties, rank high in importance. And it will surely remain so. If you have met many scientists, there should be no doubt about the significance of this.
Granite is found in the ground of Tohoku, spreading over a length of 50 kilometers. This solid rock, which withstood the earthquake, is the optimal environment for constructing a high-precision accelerator. In order for post-earthquake Tohoku to revive and join with the dreams and hopes for our children's generation, the robust driving force for realizing the future vision of Tohoku is this century's international science project.
After the International Research Center is built in Tohoku, not only will new technology be produced, but also unimagined innovative talent and possibilities will emerge into the world. We expect entirely new dimensions of innovation.
Scientists and technologists from around the world are supporting recovery from the earthquake and providing assistance to Tohoku. To revitalize the empty space left by the earthquake, Tohoku is now using its inbred resilience to apply its passion to inviting the ILC.